Hello, welcome viewers. Welcome to the class of the numerical techniques. So we shall continue over the topic. Further from our previous one, we were discussing about the Gaussian quadrature. Or a Gaussian quadrature, it is also known as the Gauss-Legender's method. It has the two procedures, 2-point formula and the 3-point formula. Last time we discussed about the 2-point formula, and that was the straightforward formula within the standard limits -1 to 1. Now, let us see what's about the Gauss-Legender's 3-point formula. There is no change, only there is change in the formula only. Rather, the rest of the working is the same in the both the cases. Let us see, it is Gauss-Legender 3-point formula. It is the other name of the Gaussian quadrature which we were discussing in the previous lecture. Gauss-Legender's 3-point formula, its integration from again -1 to 1. It is the standard one of any function f of x dx is equal to 1 by 9, then 8 times f of 0 plus 5 times f of minus under root 0.6 plus f of under root 0.6. You see, there was 1 by under root 3 and 1 by under root 3, and this term was missing in the 2-point formula, and limits are the same. It is the standard limits. If the given function does not obey this rule, then we will have to change it into the standard form that we will see today, that how to change the function which is not into the standard form. Now again I repeat, the changing of the limits has the same procedure in the both cases, either in the 2-point or the 3-point. Rather, it is algebraic function or it is a trigonometrical function. There is no difference except other than the formula. Let us see an example. Evaluate the integration from 0 to 1 dx upon 1 plus x using Gauss-Legender 3-point formula. Remember, it may be 2-point formula. The procedure will be same for the both. Which are we going to follow? There will be a difference only in the last steps, and we will note down that here. First of all, we see the given function, it doesn't obey the basic rule of the GL integration, that is -1 to 1. Then how to convert it? The first step is that put x is equal to, there may be any variable, say yt, x is equal to half of b plus a plus b minus a into t. Here a is equal to 0, lower limit, and b is equal to 1. A is equal to 0, b is equal to 1, and t is the new variable we introduce in place of the x. It can be taken any other, that is equal to half of, it is b, 1 plus 0 minus 1 minus 0 into t. That is equal to half of 1 it is plus, so 1 plus t, that is equal to half of 1 by 2 into t, that is x. Now we differentiate it, dx is equal to 0 plus 1 by 2 into dt, or dx is equal to half of dt. As the variable has changed, now we will have to change the limits by using this property or this substitution. See, when x is equal to 0, it is the lower limit. When x is equal to 0, from equation number 1, from 1 we see here put x is equal to 0, 0 is equal to 1 by 2 into 1 plus t. This implies 1 plus t is equal to 0. This implies t is equal to minus 1. And no upper limit, when x is equal to 1, from equation number 1 is equal to 1 by 2 into 1 plus t. 2 is equal to 1 plus t, or t is equal to 1. Now if we substitute the values of the limit, we see our function has reduced or changed into, from 0 corresponding to 0 we get the new limit, that is a minus 1, t minus 1, and corresponding to 1 what we get, that is t is equal to 1, and function changes from, what is dx? Dx is dt by 2 into 1 plus x, and x is half of 1 plus t. Now this function is in the standard form minus 1 to 1. Let's calculate the denominator, that is minus 1 to 1 dt divided by 2. Here we take LCM 2 plus 1 plus t, that is equal to integration dt upon 3 plus t minus 1 to 1. Now it is a comfortable zone of the problem, Gauss-Legendar form. Now it is in the standard form, rather the variable has changed. Rather we have changed the variable, along with that we have also changed the limit. So we need not to go for the resubstitution, we will proceed further from here. Now we apply the 3-point formula. Up to this we see the calculations are same, rather it is a 2-point formula or it is a 3-point formula. Only after this step, if it is 3-point, we will apply 3-point formula. If it is 2-point formula, we will apply 2-point formula. Otherwise the rest of the working is similar in the both cases. Either it may be a trigonometrical function or it may be an algebraic function. Now here we apply the 3-point GL formula, that is equal to f of, that is I is equal to, it was 1 by 9, f of 0, 8 times f of 0, we will calculate it, plus 5 times f of minus under root 0.6 plus f of plus under root 0.6, that is equal to 1 by 9 into 8 times f of 0. Here is the function, that is function is 1 upon 3 plus t. If we put t is equal to 0, we get 8 into 1 by 3 plus 5 times f of, it is 0.6, 1 upon 3 plus under root of 0.6, 3 minus this, plus 1 upon 3 plus under root of 6. If it were the 2 point, we would have used the 2 point formula here. Now we can calculate it. Simple arithmetic problem now. That is equal to 1 by 9, that is 8 by 3 plus 5 times, we can take here LCM, 3 plus root 6, 3 minus 0.6 into 3 plus under root 0.6. We get 3 plus under root 0.6 plus 3 minus under root 0.6. It cancels. That is equal to 1 by 9 into 8 by 3 plus 5 times 6 upon 9 minus 0.6. And that's equal to 1 by 9 into 8 by 3 plus 5 times into 6 upon 8.4. That is equal to 1 by 9 into 8 by 3 plus 30 upon 8.4. And that's equal to 1 by 9. We can calculate it now. 8, 3 is equal to 2.67 plus 3.57, and that's come to be 2.67 plus 3.57, that's divided by 9. That is equal to 0.6933. That is a complete calculation for the Gauss-Legender's 3-point formula or 2-point formula. Only we change the calculations from this step. Either if it is 3-point, we use this formula. If it is 2-point, we use the 2-point formula. That is the difference in the both the cases. Otherwise, the calculations are same. It is the Gauss-Legender's integration, or we call it the Gaussian quadrature.